these are the notes for examples 4 through 6 for notes 8.2b. All right, so let's take a look. It says determine the value of the variables for which of the following quadrilaterals and prove that they are a parallelogram. Okay, so let's take a look here at what we've got. We've got 3 angles. We've got 2 consecutive angles. They are on the vertical, but one has a Y and one has an X. Let's check the diagonals. Angle Q and angle S are opposite angles, and they are on the diagonal, and they both have X's. We know that opposite angles are congruent. And so therefore we can set up an equation, 2x plus 20 equals 3x minus 25. We can do a little algebra and subtract 2x from each side, and we get 20 equals x minus 25. We'll add 25 to both sides and get x is equal to 45. All right, from there we can add up here and go and multiply, or go and substitute it in. 2 times 45 plus 20, that's 90 plus 20 equals 110. Let's verify that angle S has the same angle measure. I'm going to substitute 45 in for x for this. 3 times 45 minus 25. 3 times 45 is 135, minus 25 is also 110 degrees. Check there. Now we said earlier that angle R and angle S are consecutive, and consecutive angles are supplementary, meaning equal to 180 degrees. All right, so we can say that 2x plus 20 plus 5y is equal to 180 degrees. We already have a value for 2x plus 20, which is 110, plus 5y equals 180. So let me just subtract that away and say that 5y is equal to 70, divide by 5, and we get y is equal to 14. Boom, we're done. Let's go on to number 5. In this example, we notice that we've got two different diagonals, MP and, let me get my cap off here, LN. Let's take a look at LN. 2y is equal to 5x minus 1, because we know if it's a parallelogram, our diagonals bisect it. Now, MP also has a value. The first part is m at 4x minus 2 and 2x. Those are both in terms of x, so let's use our pink diagonal to get us value for x. So we're going to take our diagonal of MP and say that it is bisected, and we've got 4x minus 2 is equal to 2x. I'm going to subtract 2x from both sides and get 2x minus 2 equals 0. We're going to divide, whoops, we're not ready for that yet. We've actually got to add 2 to both sides first. Don't get ahead of yourself. 2x equals 2, and now we can divide and get x equals 1. Let's substitute 1 back in and see if that works. 4 times 1 minus 2. That gives me 4 minus 2 is 2, and 2 times 1 is 2, also a value of 2. Check. This diagonal is truly bisected. Now, let's take that value of 1 as we're looking at an x and y value to see if we can get a value for this portion of the diagonal. 5 times 1 minus 1 is equal to 4. Now, I'm going to look at this diagonal here and say that 2y is equal to 4. I've just figured out that right here. I'm going to divide 2 away, and y equals 2. Let's check this. 2 times 2, that gives me 4. And we also already know that the value of this term right here is 4. Check. I have a parallelogram that is a quadrilateral. All right, number 6 is our last figure here, and I think it's kind of a doozy, so let's take a look. We're given quadrilateral A, B, C, D, and they want to know if it's a parallelogram. We need to explain. So let's see what we've got. We have a few theorems that we can use that'll help us in this journey. And we're also going to have to recall some old information. All right, so here we go. We see that we have a 10 and a 10 when we look at our sides. As far as sides of a parallelogram, we know that they have to be congruent and parallel. Well, I have congruent. Let's see if I can make parallel. I'm noticing here I have this angle and this angle. They're on opposites, which makes me think of alternate interior angles. Well, let's see if I have some triangles that'll back that up. So let me outline this triangle and this triangle. And let's see what we've got. We've got a measure of 10, an angle, and a common side. In my yellow triangle, I have the same thing. A measure of 10, an angle, and a common side. Therefore, triangle ABD is congruent to triangle CDB by side angle side theorem. Because I have two congruent triangles, their corresponding parts are congruent. This is a transversal, and these are alternate interior angles. With that being said, line AB is parallel to line DC. And yes, we have a parallelogram. Now, let's look at B. It says find the measure of BC. Well, we know that it has to be congruent to AD, so it has a value of 11. Find XC. We know the diagonals are bisected, and AX is 7. That means CX must be 7. And finally, we're asked for the value of DB. This time it's the entire length of the diagonal, and DX is 8. That means BX must be 8. I'm simply going to add 8 plus 8, which gives me 16.